Okay, so two examples on integral techniques that I'd like to do in this video. All right, so first find the integral. Okay, now when I look at this, there's not a ton of options for u. Okay, so if I were to pick u equals 1 plus x, then du would equal dx. Okay, when I look at my u substitution, I would have 3 over 2 root x times u times du. Okay, well that doesn't do me a whole lot of good because now I have u, but I still have x in my integral. Okay, another possibility, what if we just let u equal x? Then again, du would equal dx. So if I make all those substitutions, 1 plus u times du. All I've done is rewrite the exact original integrand with a u instead of an x. Okay, so sure, all the variables match, but it doesn't do me any good for integrating. So the only other option we have for u, let u equal the square root of x. Du would be 1 over 2 root x dx. I'm going to solve this for dx, and I get 2 root x du is equal to dx. So now I'm going to make all my replacements. So I have 3 all over 2u times 1 plus x, and then dx is equal to 2 root x du. All right, we got all sorts of things going on here that don't look right. I still have u's, but I also have x's here. Okay, so let's check this out. Let's remember that u is equal to the square root of x. So we can do one of two things here. So if u equals the square root of x, wherever I see a u, I can replace it with the square root of x, or vice versa. Now at this step, those guys cancel. Secondly, this 2 and this 2 cancel. So now I'm left with 3 times the integral. Okay, so at this step, I want to integrate with respect to u, but I still have an x in there. Okay, so one thing that we haven't looked at, okay, this is the first example that you're seeing, and I'm going to do another example using it. This relationship, you can manipulate that relationship any way you need to. We use that relationship if it's a definite integral. We plug in the x to get the corresponding u and replace our boundaries. So using that relationship then, if u equals the square root of x, then u squared is going to equal x. So now into my original, I'm going to replace x with u squared. Now when I look at the form of the integrand, I'm integrating with respect to u. U is my only variable, so now I can proceed. Okay. Now before I do that, because I'm just thinking of a question you might have, back at this step here. So if I were to look at this step again, 3 all over 2u 1 plus x times 2 root x du. Okay, I used that relationship and I replaced u to be the square root of x. But I could have taken this square root of x and replaced it with u because it's the same exact thing. If they're equal to each other, I can substitute in whatever piece that I want. Still verifies that those u's cancel. 2 divided by 2, those still cancel. So no matter which way you solve it, that would be the resulting integrand. So even after canceling them, we still need to make one more u substitution. Okay, so now let's work with this. So now I have 3 times 1 over 1 plus u squared du. Okay, now when I look at this form, there's no other substitutions I can make. So now we got to be thinking inverse trig. A squared is equal to 1, which makes A equal to 1. And then U squared equals, this is a little, so it fits the form directly for arctan. So this would be 3 arctan of U plus C. Okay, but the original problem asks us to integrate with respect to x. So then I just have to make sure that I go back and I'm replacing with my original U substitution. And after our third attempt, right, that was the U substitution we made. We said U is equal to the square root of x. So manipulating U is an acceptable method to solve these problems. So let's look at another example. Okay. The one thing that I really want you to shy away from is thinking that U will be equal to x. Because if you pick U to be x, then all you're doing is, again, you're just rewriting the integral with a U instead of an x. You're not changing, you're not substituting, you're not manipulating the integral at all. So now here, the only other option we have for U, and now this truly is an inside function of 2x minus 1. So du will equal 2 dx. So I have 1/2 du equals dx. Okay, additionally, it's a definite integral. So if x equals 1, so I'm coming back to this. If x equals 1, u equals 1 as well. If x equals 5, u equals 10 minus 1 equals 9. Okay, so now I have the integral from 1 to 9, x divided by square root of u times 1/2 du. Okay, so I'm replacing what I can. So now when we look at this, I'm integrating with respect to u, but I still have an x there. Okay, so even if I bring this 1/2, my coefficient out front, I'm going to bring this, I'm going to make that u to the negative 1/2, and now I have du. When you get a problem like this, go back to the original u substitution and see if that'll help at all. So my original u substitution, 2x minus 1. Solving for x, I'm going to add 1 and divide by 2. Now, it's not to say that you can just stop here. You have to make sure that if you make this substitution, you're still able to evaluate it. Okay, so going back to the previous problem real quickly. We can talk about in class how I could have changed this x also to equal u minus 1, but I'll show you how it doesn't help us at all. So if I continued with that u substitution, I still wouldn't be able to evaluate the problem. All right, so let me bring this on the next slide. So I have 1/2, the integral from 1 to 9, u to the negative 1/2, and then I replace the x with u plus 1 divided by 2. So now at least all my variables are u's. Now let's use some math, some number sense here. Okay, this is multiplication, so I'm really just dividing the integrand by 2, so I'm going to bring another 1/2 out front. Integral from 1 to 9. Now I'm going to distribute this u to the negative 1/2. So multiplying like bases, add exponents, so that becomes u to the positive half plus u to the negative half du. So again, where did the 1/4 come from? This here, dividing by 2, I take my coefficient out front and just multiply it by another half. A half times a half is where I get my 1/4. Now when I look at my integrand is just simply a power rule. So 1/4, add 1 to the exponent, divide by the new, plus add 1 to the exponent, divide by the new. Now I'm integrating this from 1 to 9. Alright, I'm going to keep my 1/4 out front until I'm done. So first I got to plug in 9. So I have 2/3 times 9 to the 3/2 plus 2 times 9 to the 1/2 minus my answer when I plug in 1. So I'm just going to write 1 to any power is 1. So I'm just going to not even mess with those exponents there. So 1/4. Square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 gives me 18. Square root of 9 is 3. 3 times 2 gives me 6. Minus 2/3 minus 2. Just distributing that negative. 18 plus 6 is 24. Minus 2 gives me 22 minus 2/3. All right, 22, that would be 66/3 minus 2/3. So that gives me 1/4 times 64/3. 64 divided by 4 gives me 16. So 16/3 is my answer. My suggestion for you after seeing these two, I mean, I can give you 2 more to practice like this, but I would say redo these problems on your own and make those substitutions and practice with manipulating U. That'll do it for this video.